Okay, so now we've seen the reaction itself. Now we want to know the reaction mechanism. We want to know the reaction mechanism, okay? The reaction mechanism, one of the simplest, let's go through one of the simplest, by far, the simplest reaction mechanism in the whole world. So this reaction mechanism just consists of 3 steps. Now, reaction mechanism, we are saying, how does this reaction actually happen? Okay, is that one reaction of alkanes, which is not combustion, the halogenation, okay, where we are swapping a hydrogen with a halogen. We want to know how does it actually happen, okay? So basically, first, we start with what we call the initiation. It only has 3 steps, okay? One is going to be the initiation step. And this tells you why we need sunlight, why we need UV light. What happens is we have 2 guys, okay? An X and an X. They are bonded together like this. And these are the group 7s, like chlorine and chlorine. They're bonded together. Now, what they're going to do is they're going to absorb light and they are going to split up. Now, if you see every other reaction mechanism, let me tell you right now what helps you remember this. We have 2 ways in which a bond breaks. One is where we say homolytic fission. In homolytic fission, this is fair. Homolytic, it's equal bond breaking. You have a bond. In every bond, let's say between X and X or whatever, there are 2 electrons in that bond that have been contributed because it's a covalent bond. We are dealing with non-metals here. There's no metal. So anyway, 2 guys sharing. In homolytic, it's fair. Each guy is going to receive something. So he receives this and he receives that. Okay, so what? Because each guy is receiving 1 electron, we represent it by half arrows. Okay, we represent it by half arrows. And it's going to be like that. Okay, in heterolytic fission, which is every other reaction mechanism you are going to do, it's going to be unfair bond breaking. There's going to be some guy, carbon, bonding with Br or something. Then you're going to see an arrow going like this. What is it saying? It's saying that both electrons are going to one guy. Both of them. Okay? That's what's going to happen. And if both electrons go to one guy, of course, we know that they'll be going this direction. If they go to one guy, this guy will remain being positive. Okay? Because you have stolen from him. He can't remain being neutral. And he has stolen, so he has to get negative. Okay? That's what's going to happen. So, in any other. So, in here we have homolytic. That's the whole alkane reaction mechanism. It is involving homolytic. So, let's go. Just 3 steps. You guys can remember it. So, the first thing we know that your group 7 is going to absorb energy from the light and break the bond between your 2 group 7 guys. Will break. So, what am I going to have? I'm going to have X being now a radical plus another X being a radical. So, what this means is this. When you see us showing radicals, we are saying a radical is these. Group 7 has how many electrons in the last shell? 7. So, right now, we've given him back his electron. We show it half arrow going outside. Here we do a half arrow going outside. We've given him your electron, so he is back to the normal group 7 state. He is neutral, right? He's back to his normal state. But we know he has 7 electrons in the outermost shell, which means there is 1 electron there, which is alone. The other 6 will be in pairs of 2. 2, 2, 2, right? 2, 4, 6. We call them lone pairs. But this guy is going to be alone. So if you wanted to put the lone pairs, you could always put them. They're not even difficult. Here are the lone pairs. And then we have it like this. So this guy is going to have these radicals. Okay, sometimes they like to put the radicals facing one another. That's nothing. This is just the general form if you want. Here you have your radical. So that's what's going to happen, right? The radicals are those unpaired electrons that are in the last shell. So we call them valence electrons that are unpaired. And that electron being there makes this guy be so unstable because he can't stay alone. The electron can't stay alone. So let's remove the lone pairs and let's deal with radicals for now. Okay, see how is this going to be. So basically, we had it, half arrow going there. Nice bond breaking, equal. That's the initiation step. They absorb light, okay? They absorb light. We know that the light will be UV. Then they form radicals. These radicals are very reactive things. Now, what happens? The next step is going to be propagation, where we now say we are continuing now. We have started, now we go through the steps. So what happens is we have an alkane, which will show the last hydrogen on the alkane. This is carbon with many other things. So what's going to happen is he is going to be attacked by the radical. And when he is attacked by the radical, the hydrogen from the alkane will leave the alkane and go to the radical. So there's going to be equal bond breaking again. Nice, fair stuff. So we show that this guy goes to hydrogen. Then this one, look at where it goes. He is going to the plus sign because we are showing that he is combining with the X. This hydrogen, he's combining with the X. Then one electron goes. So the electron for hydrogen is going and meeting the one for your radical. And you know what you're going to get? R now being the radical. Okay, this R is now going to remain being a radical because he is now having an electron which is unpaired. Okay, and then what do we have? H times X, H and X becoming HX, right? And then when this happens, do you think this radical, this R radical, the carbon radical is going to keep quiet? No, he's going to fight back. So this carbon radical will come back. And you know who is going to attack? Another combination of group 7, okay? That has not yet been excited. He's going to attack a group 7 molecule. And you know what's going to happen when he attacks a group 7 molecule? What's going to happen is he will put his radical, his electron, okay? This electron, that is the radical electron, and it will meet one of the group 7 guys' electron, and the other group 7 will be given his electron and told to become a radical. Okay? So what's going to end up happening is we now have Rx and we now have an X radical. And you say, so we are back where we started? No. R had an H, but now R is fine, but he now has an X. So yay, we've won. We've given him an X. So there we go. He is already now a halogenoalkane. So we have won. So this step works. This thing works, this two-step reaction, because he's going to go to look for comfort at a halogen. And when he gets halogen comfort, he no longer has the hydrogen. He now has the halogen. So that's what's going to happen. And we have our halogen radical again, which is similar to the one we started with. Okay? This is going to be a propagation. Then now we have termination. What makes this reaction end? What makes this reaction end? Termination is basically when two radicals meet. Full stop. When two radicals meet. And what are the types of radicals we have? The halogen one. So if a halogen radical meets another halogen radical and they give their electrons together, okay, this is what shows them combining, then they'll form XX. That's a type of a termination. Another one is if you have the R radicals, okay, these ones are, we call them the what? These ones are the alkyl radicals, okay, the carbon radicals. Here we have them. If they come together and form your carbon, your this longer methane form molecule, then that's a termination. We never should have two radicals meeting. What is the last type? We can have an R radical meeting an X radical and them combining, okay? Here is another type of a termination. So whenever two radicals meet, it's a termination and we have Rx. That's it. That's how simple it is. That's how simple this thing is, okay? Now let's do an example because they could say use methane. So we do the methane example, okay? Methane and CO2 example. Let's do an example of this reaction using methane and CO2. Remember, if you want to show your lone pairs, you can just come here and put lone pairs like this. You know there will be 6, okay? On each one. After you've done everything, you can just be going to the X and putting the lone pairs, okay? Not necessary, okay? All right. Now we can go. You can put them if you want. Now we can go to the last. We are showing an example of methane and chlorine. So we have chlorine. Remember, step 1. So step 1 is going to be initiation, right? Initiation, it is when group 7, not chlorine, and not methane, but group 7 absorbs light. So initiation, you have your chlorine bond with 2 electrons like this. And what's going to happen is he is going to absorb UV light, okay? And what's going to happen? You have 1 electron coming here, 1 going there. And we are going to form 2 chlorine radicals. Then step 2 Step 2 is going to be the propagation. Okay, propagation, yes, which means continuation. What's going to happen? This Cl radical is going to meet a methane. So you have your methane. You can put your methane in any way. Here we can put it. Here's the way they've put it in displayed structural formula like this. Okay, here's your methane. And what do we know? The hydrogen, one of the electrons, there are 2 electrons in here, right? This one will go and meet with the radical. And then this one will go back to your carbon. Okay, this one will go back to your carbon. So at the end of the day, what am I going to have? I'm going to have, at the end of the day, I'm going to have a CH3 radical. So I could put it like this if I want to show it in displayed formula. Okay, H, then here is the radical plus HCl. Okay, there we go. This is going to be my hydrochloric. Then what's going to happen is, do you think he's going to keep quiet? Never. He's not going to keep quiet. So what am I going to have? I'm going to have a chlorine now. Remember, he always attacks a group 7. He is going to meet this angry radical, which says the battle is not over, bro. The battle is not over. And what's going to happen is, we have 2 electrons here. One goes here, then one is going to the plus sign to meet this radical guy. And at the end of the day, what are we going to have? We are going to have it being back to this format, but this is now a chlorine. And we have hydrogens here, plus chlorine radical. Okay? And woo, we've done the job. We've done the job, because at the end of the day, we are back to a chlorine radical, which is what we added to this guy. But instead of a hydrogen, we've made him have a halogen, group 7. So we've done the job. Now we can go to the termination. Okay, now we can go to the termination stage. Okay, termination stage, what's going to happen is just 2 radicals will meet. So let's have them. So we could have written it as CH3 radical. Instead of putting it in this format, you can just write it as CH3, then put the radical here. You can do that. Okay, so CH3 radical is going to meet another CH3 radical, and they are going to terminate each other. What will we end up having? We are going to end up having a CH3CH3. Then another way is a chlorine radical meets another chlorine radical. Okay, then what's going to happen? You can put the radical at the back of a chlorine. Then, of course, we know they will combine and form Cl2. Then what's the last one? We have this guy, okay, meeting a Cl radical. They come together, and we are going to get CH3Cl. And that's going to be the end product. And you are done. And we say, well done to you. That's how easy it is. Okay? Bye.